A black body is at the temperature T, at which this black body is radiating all the electromagnetic spectrum, ranging from the very long radio wave to the extremely small wavelength of the gamma rays. But according to the quantum mechanics, this radiated energy is not radiated in the equal amounts, but every light have a different intensity. And how does this intensity changes? This intensity changes according to this curve. All lights are radiated but with a different intensity, and specifically this wavelength of the radiated light is has a maximum intensity, means maximum energy radiated per second per unit area. So in this question we will see that if the temperature is changing, if the temperature is increased or variable, then how does this peak wavelength varies with the changing temperature. And one point to be noted, this area is proportional to amount of energy radiated, which means when you will increase the temperature, this black body will radiate more energy. So that's why this area will also increase. Let me show you. According to Wien's law, we know that the product of the peak wavelength and the temperature is constant. What does that mean? It means that the peak wavelength, the wavelength of the light carrying maximum energy, is inversely proportional to the temperature of this black body. It means that if this curve is formed at the temperature T, and right now if I draw another curve that is, for example, like this, as you see, and of course it has also the less area under its graph, this new graph, which means it is propagating the less amount of energy. So you see that its peak wavelength is greater than lambda p prime is greater than lambda p, which means that its temperature T prime is less than T, which means that this curve is formed by this black body at the less temperature than this temperature, which means that these two quantities are inversely proportional to each other. So option A is the right answer.